Here on our good old planet Earth, water is literally everywhere. Not only in the oceans and seas, but also in the atmosphere, in the ground, and even in our cells. It covers as much as 71% of the surface of our planet. Looks like our planet should have been called water and not Earth. But what would happen if water and land were distributed equally? What if half of the planet became land and the other half was water? Well, let's find out. First of all, let's discuss what we mean by equally. Despite all the things mentioned earlier, there's actually not so much water on our planet. Yeah, if you collected it all in one giant drop, it'd be slightly larger than the United States in size. And all this amount of water would only be 0.02% of the total mass of Earth. So, it turns out that all these horrifying unexplored ocean depths are basically nothing. And now, just imagine if we changed the composition of our planet by leveling the volume of water and land. What would happen then? Then, we'd get a very creepy ocean planet. The planet would look like one boundless ocean. It'd be very unlikely that you'd find even a couple of small islands on it. And if you did find them, they'd probably be the tops of huge underwater mountains. This world would be practically uninhabitable. If you were on its surface, you wouldn't be able to see the sun or anything else in the sky. You wouldn't know what time of day it is or where exactly you are. All because of the incredibly thick fog and clouds. This kind of weather would be permanent on such a planet. Moreover, you wouldn't even understand where the fog ends and the water begins. All because the humidity would be that high. But could there still be life? Well, maybe inside the ocean itself? Unfortunately, this is also quite unlikely. You see, to get to the bottom of this ocean, you'd have to swim vertically down, not for several hours, but for several days. And even after such a journey, you wouldn't see the bottom yet. The ocean wouldn't be bottomless, of course, but the seabed would consist mainly of very hard, impenetrable ice. But not the kind of ice we're used to. This ice would be exotic. There are different types of it, called Ice 5, Ice 6, and so on. Usually, these types of ice aren't as cold as regular ice and may not melt even at high temperatures. And there would be almost no algae or anything like that. So fish would simply have nothing to eat. That's why, if life appeared on such a planet, it would be a miracle. This life would have to withstand a pressure of more than 20,000 Earth atmospheres. Even the most horrifying monsters from the Mariana Trench would be nothing in comparison to the creatures you'd find on this ocean planet. But could we, humans, live there? Well, theoretically, yes, but it would be extremely hard. We could create something like giant underwater stations, but we would still have thousands of problems. Where to get food and other resources, how to repair stuff, and so on. So it would be far from the best option. Okay, now we know that an ocean planet doesn't sound too endearing. What about another option? What would happen if the surface of the Earth was 50% water and 50% land? For this to happen, we'd need to reduce the current amount of water from 71 to 50%. In this case, the sea level would drop by about 2 miles, and a quarter of our planet would become dry land. Although it doesn't sound like much, the consequences would be disastrous. Right now, there are 5 interconnected oceans on Earth: Atlantic, Indian, Pacific, Southern, and Arctic. But if we lowered the sea level, all these oceans would simply disappear. They'd turn into separate closed reservoirs and seas. On the contrary, all the continents would merge into one giant landmass, almost as if we swapped the land and water. At first, it would seem pretty cool. Now, you could literally walk around the world. However, the amount of land you'd have to travel would also increase. Every continent on the planet would grow in size. All this new territory would be approximately equal to the current area of Asia, Europe, Africa, and North America combined. Well, that would be a huge mass of unused space. But what would we find on these new territories? Most of them would be pretty flat. But in places where there used to be deep oceans, you would see vast corridors and steep crevices. Now, here's another cool thing. Most of the sunken cities would return to the surface. And no, unfortunately, we wouldn't find Atlantis among them. But there would still be a lot of other cool places. For example, the ancient Roman city of Baia, which, according to legends, was basically a paradise on Earth with all its luxurious villas and gardens. Or Heraklion, the city that went under the sea thousands of years ago and was considered a myth for a long time. So yeah, we could organize tours to these ancient places. But of course, not everything would be fun and games in such a world. Due to a severe loss of water, ocean currents would be disrupted, and this would lead to very serious climate problems. The ocean absorbs the heat radiated by the sun. Thanks to the currents, this heat is distributed all over Earth, which creates a stable and pleasant climate. But if these currents were disrupted, then the temperatures on Earth would become more extreme. It would get much hotter near the equator and even colder around the North and South poles. So yeah, unfortunately, the Antarctic ice wouldn't save us. It would be quite the opposite. The regions around the North and South poles would completely dry out, basically turning into dry, cold deserts. In addition to heat, water also absorbs carbon dioxide from the air, and since the oceans wouldn't be able to absorb it, this gas would begin to accumulate in the atmosphere. This poisonous excess would cover the entire planet. The average temperatures would increase, and the whole planet would start to dry out slowly. Massive forest fires would break out, and so on. Sound familiar? Now, to make matters worse, there would be nothing to extinguish these fires, because, rains can't form from nothing. So yeah, the precipitation levels would fall, and this would lead to dangerous droughts. We'd get a bunch of new deserts on all the continents. Despite getting all those new territories, it's unlikely that we could somehow build new cities and towns there. Many of these territories would be uninhabitable, not only because many forests and plants would disappear, but also because most animals would migrate to more pleasant places. As a result, we would have great difficulty finding any food at all. So, all life on our planet, plants, animals, and people, would have to adapt to new living conditions. They would have to evolve quickly and get used to the constant shortage of water. Animals, for example, could shrink in size because of this. Many of them, due to the lack of grass and moisture, would switch to a strictly carnivorous diet. And of course, we would have to say goodbye to the huge abundance of marine life. Many fish would disappear forever. Humans, most likely, would make a big evolutionary step backward. Not only because we would lose a large number of resources and move to new territories, but also because we would also lose access to one of the most important sources of energy in the world, hydroelectric power. Without electricity, many factories would stop working. To say that this would cause a large-scale crisis for us all is sadly obvious. So, our current ratio of water and land is the best possible option. If there was too little or too much water, the consequences would be awful. That's why we need to protect the current conditions with all of our might. So scientists have this idea that some exoplanets, which are worlds outside our solar system, might be water worlds. They orbit their distant stars, covered by global oceans. Even better, some experts claim that our Earth was once the same, a vast expanse of the ocean, and just a bit, if any, visible dry land. At the moment, water makes up 71% of Earth's surface. Our planet experiences continuous movement of water. First, water evaporates, rising from the ocean surface to the atmosphere. Then rains fill lakes, rivers, and underwater reservoirs. Eventually, all this water ends up in the ocean again. Water also plays an extremely important role in the processes happening below the ground. For instance, water content in magma determines how explosive a volcano can be. Anyway, one of the most burning questions about Earth's water is, where did it all come from? It's very unlikely that our planet was simply born this way. The thing is, water has a way lower condensation temperature than some other substances, like silicates or iron. These materials compose the terrestrial planets in the solar system. In the early history of our planetary system, the region where Earth formed was too hot for the oceans to condense at the same time as our planet appeared. So, there's this idea that water appeared on Earth when melted meteorites hit the surface of our planets. Well, scientists disagree. Researchers analyzed some melted meteorites that had been hanging around in space since the formation of the solar system about 4.5 billion years ago. They discovered that those space rocks had extremely low water content. Even more surprising, they were among the driest extraterrestrial materials ever found and examined. In other words, once they melted, there was essentially no water left. These results were very important, since they helped scientists rule out melted meteorites as the primary source of water on Earth. Plus, we can say that this revelation was kind of eye-opening. Imagine the unlikely conditions that aligned to make our planet habitable. Getting water and developing surface oceans on a planet so small and so close to the Sun is a great challenge. If Earth had formed just a tiny bit closer to the Sun, our planet would have been much hotter, and all the water would have most likely evaporated. If it had been farther away from our star, Earth would have turned out to be much colder, and the water would have probably frozen into ice. The team of scientists managed to analyze 7 melted meteorites that had crashed into Earth. Those must have splintered from at least 5 space objects known as planetesimals that later collided to form the planets in our solar system. These planetesimals took part in something known as melting. They got heated up as a result of the decay of radioactive elements in the early solar system. This caused them to separate into layers with a core, mantle, and crust. Plus, the heating and melting of planetesimals apparently led to near-total water loss, regardless of how much water they started with. As for meteorites, some of the samples arrived from the inner solar system where our planet is located. The conditions here are relatively warm and dry, so it's no wonder the meteorite samples didn't contain much water. But a few samples were from the colder outer reaches of the solar system. That's from where the water is believed to have come to our planet. But if this water hadn't been delivered by meteorites, what kinds of objects could have carried it all the way across our planetary system? There's one more theory, though, that hydrogen inside our planet played an important role in the formation of the oceans. At the same time, these two ideas are not mutually exclusive. Water could have been delivered to Earth by impacts from some space bodies, like asteroids from the outer edges of the asteroid belt, spanning between the orbits of Mars and Jupiter. And some amount could also appear inside our planet. There's also a theory that claims that Earth gradually grew by accumulating icy planetesimals about 4.5 billion years ago. At that time, it was still only 60 to 90% of its current size. According to this theory, Earth managed to retain a certain amount of water in some form throughout the process of accumulating its mass, and as a result of large impact events. It sounds quite plausible. The examination of the chemical composition of lunar samples brought to Earth by the Apollo 15 and 17 missions indicated that water had already been present on our planet before the Moon was formed. So far, all these ideas remain just theories. At the moment, we don't know for sure how water appeared on Earth. What we do know is that there are many other space bodies that have water in this or that state on their surface, or under it. Let's start with our dear Moon. On Earth's natural satellite, water can be found all over the surface, but it's probably not the water you imagine. You won't find pools of liquid water there. On the Moon, it's mostly ice. Some places have more water than others. For example, the poles of the Moon are regions that never get any sunlight. That's why they're extremely cold, and there's a lot of ice there. Plus, the ice in these areas is often mixed with the lunar soil and hidden deep below the surface. Then there's Jupiter's moon Europa. Astronomers consider this world to be one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, the temperature, pressure, and chemistry are far different on Europa. Scientists don't know yet how the ice behaves there. That's why they can't understand how deep or large the water reservoirs on Europa are, or how long they need to refreeze. Enceladus is the 6th largest moon of Saturn. It's not really large, only 314 miles across. This makes the space body small enough to fit inside Arizona. Wait, we should try that. Never mind. When the Cassini space probe first arrived at Saturn, Astronomers thought that Enceladus was going to be a frozen ball of ice. But then they saw plumes of icy particles and water vapor erupting from geysers on the Moon's surface. It became clear that there was a massive ocean between the Moon's rocky core and its icy shell. If you've been imagining Mars as an extremely dry place, you need to listen to this. Scientists think there could have been a lot of water on Mars in the past. What makes them think so? They found lots of ancient river valley networks and lake beds on the surface of the red planet. Plus, on Mars, there are minerals and rocks that can only form in liquid water. Mars might even have experienced terrible floods 3.5 billion years ago. These days, there's still some water on the red planet. It's true that Mars's atmosphere is too thin for this water to stay in its liquid form on the surface of the planet. But under the surface, it's a different matter. You can find water in Mars's polar regions, but the only place where this water is visible is at the North Polar Ice Cap. Sometimes salty water flows down crater walls and hillsides, and there are tiny quantities of water in the planet's atmosphere, but it only exists as vapor. Since we know for sure there is liquid water on Mars, could we possibly use this water during the human-operated mission to the red planet? If we manage to do it, spaceships coming from Earth wouldn't have to bring their own water. It would make the cargo way lighter, which, in turn, would decrease the cost of the mission. We would just need to take enough water to get to the red planet and bring along the equipment needed for filtering Martian water to make it drinkable. Well, it sounds simple enough. So, we don't have all the details about how the universe, our solar system, and its planets came to be. But one thing's for sure, Earth didn't just pop out of thin air. Scientists have recently made an intriguing discovery that suggests our planet may have formed way faster than we previously thought. You see, up until now, experts believe it took over 100 million years for Earth to take shape. The common belief was that lucky collisions with water-rich asteroids brought water to our planet. A recent study, however, proposes a whole new perspective. According to these researchers, there's evidence that Earth formed through the rapid accumulation of tiny pebbles, each roughly the size of your fingernail. In this scenario, our awesome planet emerged in only a few million years. And here's the mind-blowing part. They suggest that water being here isn't just some happy accident, but a natural result of the formation process. Now, this discovery has implications that go beyond Earth itself. If our planet formed quickly and water was an integral part of the process, it means the chances of finding habitable planets in other solar systems are way higher than we ever imagined. If we stumble upon other planetary systems with planets orbiting sun-like stars at the right distance, there's a good chance we'll find water there too. That's some nice intergalactic real estate that we might just be able to relocate to, should we ever get in trouble here on Earth. The old-school view was that planets slowly took shape through countless collisions over millions of years. According to that theory, water on Earth would have been a random stroke of luck, maybe caused by comets packed with water crashing into the planet during its later stages of formation. The new study introduces an alternative theory too. Picture this: a young sun surrounded by a disk where the planets are popping up. This disk is filled with tiny dust particles. Now, here's where it gets exciting. Once a planet reaches a certain size, it acts like a cosmic vacuum cleaner, swiftly hoovering up all the dust in its path. In just a few million years, this tiny planet grows into the size of Earth. This not only shapes our incredible planet, but guarantees water's existence too. As the planet gobbles up the dust, it also snags icy particles floating around in the disk. So, if we use Earth as an example, it suggests that whenever a similar planet forms, it's bound to have water naturally. There's no way for us to travel back in time and see for ourselves, so there are more theories about how planets are born. Let's dive into a different scenario called the core accretion theory. Picture a big cloud of dust twirling around in space. That's where the action begins. Over time, this cloud starts pulling in an astounding 99.8% of all the matter, eventually creating our sun right at the center of our solar system. Soon enough, solar winds join the party, bringing in lighter atoms like hydrogen and helium that are closer to the sun. But those heavier elements? The sun can't pull them in because, well, they're too heavy. So what do? They gather together and stick to each other, forming their own little planets. That's how Earth, Mars, Venus, and the gang got together to create round spheres. The heavyweights, like zinc and iron, sank to the middle, forming the core, while the lighter elements meshed on top, creating the crust. But wait, we can't forget about Jupiter. Its gravitational force and the Sun's were locked in an epic tug-of-war, perfectly balancing each other out. That's why we have that fascinating asteroid belt hanging out between Mars and Jupiter. Those poor asteroids never got the chance to become fully fledged planets on their own. This explains why the planets in our solar system are arranged the way they are. The inner ones, known as the terrestrial planets, like Mercury, Venus, Earth, and Mars, are closest to the Sun. They're made of denser stuff like iron, silicon, and aluminum. On the flip side, the gaseous giants, like Jupiter, Saturn, Uranus, and Neptune, are chilling on the outer edges of the solar system. These big celestial bodies are composed of lighter materials, such as hydrogen, helium, and methane. Now, let's take a trip to the outermost layer of our solar system, where the Kuiper Belt and the Oort cloud reside. These distant areas are home to ice bodies, space debris, and comets. While there may be plenty of them, they're relatively small and don't contribute much to the total volume of our solar system. The quest to understand planet formation doesn't end here. There's another mind-boggling mystery that's causing a stir among scientists: the existence of a celestial body dubbed the planet that shouldn't exist. Let's rewind a bit. Astronomers have been on a roll with exoplanet discoveries, and we've already spotted over 4,000 of them. Most of these exoplanets resemble the gas giants in our own solar system, like Jupiter and Saturn. Do you know why? It's because those massive exoplanets close to their stars are the easiest to detect. But here's the twist. A new study suggests that there's a whole bunch of Jupiter-like exoplanets just waiting to be found, and they're probably hanging out nearby. This impossible planet goes by the impossible name JG3512b, and it's remarkably similar to Jupiter, only orbiting a tiny red dwarf star. This discovery shook things up because it defied the most popular theory of planet formation. According to the prevailing ideas, it should have been impossible for such a giant planet to form around such a small star. So, what's the deal with this impossible exoplanet? Well, it turns out that core accretion, the theory we discussed earlier, can't explain its existence. According to this theory, the mass of the debris disk surrounding a young star should be directly proportional to the star's mass. But here we have a star much smaller than our Sun hosting a planet that should be way too massive for it. Something doesn't add up. Either the original debris disk was insanely enormous compared to the star, or core accretion didn't play out as expected in this particular planetary system. We've established that when talking about the Earth's formation, there's still much we don't know. But hey, we've come a long way. Back in the 18th century, a philosopher named Immanuel Kant had his own intriguing theory about planets popping up in the universe. He based his ideas on Newton's law of gravity, but added his own little twist. Kant believed that the universe started with an original substance made up of super cold, solid particles just chilling out. Then, thanks to gravity, these particles began colliding and heating up. And you know what happens when things collide, right? They get hot. According to Kant, this cosmic twirling and heating up caused some serious forces to come into play. It's like when you spin around so fast that you feel like you're about to take off. These forces led to the formation of rings of matter, like cosmic hula hoops. And as these rings cooled down, they transformed into planets and satellites. Now, not everyone was convinced by Kant's wild idea of planet formation. Critics raised their eyebrows and started questioning the whole theory. They pointed out that Kant failed to address the origin of this primordial matter. Where did it come from in the first place? Moreover, he overlooked the source of energy that propelled these particles from a state of cold stillness to a frenzied cosmic dance-off. As creative as his theory was, it soon faced dismissal in the scientific community. In short, they said, "This can't happen." Nevertheless, Kant's theory was still a step forward compared to older beliefs about Earth's origin. Take the ancient Egyptians, for example. They believed that primordial spirits, often depicted with frog heads in their native artwork, were responsible for our planet's existence. Why frogs, you ask? Well, they associated the first substance in the universe with water, and frogs just love humid environments. So, out of that initial water, a primordial hill emerged, followed by the elements of air and moisture. Ribbit.